Okay, this video has examples from the topic Pythagorean Theorem on Study Island. Let's get started. First of all, before we actually get into the problems, what is the Pythagorean Theorem and what does it say? The Pythagorean Theorem can only be used with right triangles. And it says that in a right triangle, first of all, the names of all the sides are very specific. You have the hypotenuse. That's key. The hypotenuse is the longest side of the right triangle, the longest side, and the hypotenuse is always the side opposite of the right angle. The other two sides are called legs. I'm going to label the legs A and B. It doesn't matter which leg is A and which leg is B. I'm going to label the hypotenuse C. The Pythagorean theorem states that if you multiply A by itself, so A squared, A times A is A squared, and you add that to B multiplied by itself, so B squared, that will be equal to the hypotenuse multiplied by itself, which in this case would be C squared. That's the Pythagorean theorem. A squared plus B squared is C squared. This is true for every right triangle, no matter what. So now we can go ahead and do the first problem. It says R is 25 and S is 7. What is the length of T? We have three sides, R, S, and T. So let's identify them. Which is the hypotenuse? Which is the side that is opposite the right angle? It's R. So in this problem, R is the hypotenuse, which means the other two sides are legs. So one leg times itself plus the other leg times itself equals the hypotenuse times itself. So now we can substitute what we know for ST and R. We know that R is 25 and S is 7. So 7 times itself plus the other leg multiplied by itself, which in this case is labeled T, equals R multiplied by itself, which is 25, so 25 squared. Now all we have to do is solve for T. Well, what is 7 squared? 7 times 7 is 49. So 49 plus T squared equals 25 squared. 25 times 25, and you guys can use calculators for this, but 25 times 25 is 625. So we can go ahead and use a calculator if you want. Big calculator, let me shrink that down a bit. Okay, so here we go. 25 squared. The way you would type in squared into a calculator, we're using a keyboard, by the way, is to use the caret. Excuse me, which is the shift and hitting 6. That's called a caret. And then the next number is the exponent. So 2 would be squared. So that's 25 times 25. If you type it out 25 times 25, you get the same thing, 625. Now we want to solve for T. So what we do is we subtract 49 from both sides. So T squared is equal to 625 minus 49, and that gives you 576. So to solve this, I don't want to know what T squared is, so I take the square root of T squared, and that will be equal to the square root of 576. And I'm only going to worry about the positive version of the square root of 576 because I can't have a negative length. So the square root of T squared is T, and the square root of 576, all you have to do is hit the square root button, and you're going to get 24. So there it is, 24. T equals 24. So again, one leg times itself, one leg squared, plus the other leg squared equals the hypotenuse squared. One leg was 7, so 7 squared plus the other leg squared equals 25 squared because the hypotenuse is 25. 7 squared is 49 and 25 squared is 625. If 49 plus T squared equals something, I could take 49 away from both sides and it would tell me what T squared was. T squared is 576 because 625 minus 49 is 576. So something squared is 576. What times itself is 576? Well, we find out the square root of 576 and we get our answer. So there we go. Let's do some more of these. The triangle has sides that measure 5, 12, and 13. What type of triangle is it? Well, according to the Pythagorean theorem, if I multiply The two shorter sides, 5 squared plus 12 squared, if I multiply them by themselves and add them together, if it's a right triangle, it will be the longer side multiplied by itself. Let's see if that checks out. 5 squared is 25, 12 squared is 144, and 13 squared is 169. What's 25 plus 144? It is 169. So, did this work out like the Pythagorean theorem says it should for a right triangle? Yes. 5 squared is 25, 12 squared is 144. Those two added together do indeed equal the longer side squared, which is the hypotenuse now that we know it's a right triangle, which is 169. So this is a right triangle. Depending on whether those two things, the two shorter sides multiplied by themselves and add together, depending on whether it's more or less than the other side squared, will tell us if it's an acute, obtuse, or some other type of triangle. But it only works for right angles. It's going to be exactly like that. Next, one of Madison's hobbies is to locate hidden geocaches. To find yesterday's geocache, Madison was instructed to start at a water fountain at a local park. Then the directions had to walk 15 yards due west and 8 yards due south. If this was the location of the cache, how far was it from the water fountain where she started? Well, let's draw that out. Here's Madison. She's at this point. First, she walks 15 yards due west. West, it's 15 yards. And then 8 yards due south. So south, 8 yards. So this is where she ends up. She's this distance away from where she started. This makes a right triangle. And the distance away from where she started is the longest side of that right triangle. It's the hypotenuse, which we labeled C before. So I'll go ahead and label that C right now. So let's use the Pythagorean theorem. One side, one leg, times itself, plus the other leg times itself is equal to the hypotenuse times itself. 8 times 8 is 64. 15 times 15 is 225. So those two together equal C squared. Don't be afraid to use your calculator on this. It's okay. You have 8 squared plus 15 squared equals 289. And that's, again, 64 plus 225, same as we did there. So 289 is equal to C squared. Of course, I'll take the square root of both sides because I don't want C squared, I just want C. So the square root of 289 is the square root of C squared. And of course, the square root of C squared is just C. So we have the square root of that number, and we get our answer, 17. So 17 is our answer. Which of the following measurements could be side lengths of a right triangle? Oh, look at this. They're all in square root formats. That could be a bummer. Well, let's figure it out. It still holds true that the two shorter sides multiplied by themselves and added together have to be the square of the other side. So let's take a couple of these and see what happens when we square them. So A, the two shorter sides are obviously the square root of 48 and the square root of 12. Those are smaller than the square root of 60. So for this to be a right triangle, the square root of 48 squared plus the square root of 12 squared has to equal the square root of 60 squared. Well, the square root of 48 is just 48. A square and a square root cancel each other out. Plus the square root of 12 is just 12. Or excuse me, the square root of 12 squared is just 12. And the square root of 60 squared is 60. Is 48 plus 12 60? Yeah. So this checks out. That's a right triangle. What if we tried one of these other ones? What if we tried one of these? Well, the two shorter ones on B, for example, are 36, so I have the square root of that squared, plus the square root of 42 squared, and that would have to be equal to the square root of 84 squared. Hopefully you already see the problem with this. They don't actually equal each other. The square root of 36 squared is 36. The square root of 42 squared is 42. And is that equal to the square root of 84 squared, which is 84? What's 36 plus 42? That's 78. 78 equal to 84? No, those are not equal. So this these three lengths of triangle sides would not make a right triangle. But we already found the answer in A, so we don't have to check all the rest of them. I want to just make sure that you saw what that looked like. If I tried these other ones, 54 and 36, those together, added together make 90, not 96. And this one, 12 and 60 do not make 66, it makes 22. Explain the Pythagorean theorem. Which one of these is the word version of what I have been saying? Which one of those sentences says this right here? Let's check it out. The Pythagorean theorem states that if a triangle is a right triangle, then the sum of the squares of its legs equals the square of its hypotenuse. Sounds pretty good. If it's a right triangle, the sum, which means adding, of the squares of its legs, so A is a leg, B is a leg, square of the legs added together is the sum of the squares of the legs, equals the square of the hypotenuse. It's A. What's wrong with these other ones? What does B say? B says the Pythagorean theorem states the square of one side of a triangle is greater than the sum of the square. We don't want the square of one side to be greater than the sum of the square. We want them to be equal. The square of one side is equal to the sum of the squares of the other two sides. Not greater. This one says if a Pythagorean theorem states that if a triangle is a right triangle, the sum of the squares of its legs is greater than the sum. So again, we don't want the sum of the squares of the legs to be greater than the sum, greater than the square of the other side. We want the sum of the squares of the legs to be equal to the square of the other side. Last one says the Pythagorean theorem states that the square, let's try it again. The Pythagorean theorem states that if the square of one side of a triangle is less than the sum of the squares of the other two sides, then it's a right triangle. Again, that's wrong. We don't want the square of one side to be less than the sum of the squares of the other two sides. We want the square of one side to be equal to the sum of the squares of the other two sides. So again, A was our answer. Okay, we can do one more here. The triangle above has sides A, B, and C. Given the measurements, A is 3, B is 4, and C is 5. Which of the following is true? Is it acute? Is it right? Is it obtuse or isosceles? So let's go with 3, 4, and 5. Let's see. If I have 3, 4, and 5. 3. A is 3. B is 4. And C is 5. In this triangle, the hypotenuse right here is the long side C. So we're going to check and see, is 3 squared plus 4 squared equal to 5 squared? Well, 3 squared is 3 times 3, which is 9, plus 4 squared is 4 times 4, which is 16, equals 5 squared is 5 times 5, which is 25. 9 plus 16 is 25. And so they are equal. That checks out. So it is a right triangle. So both examples that had something like this that we did turned out to be a right triangle. I want to make sure that you know what would make an obtuse triangle and what would make an acute triangle. First of all, what are they? An obtuse triangle is a triangle where one of the angles is bigger than 90 degrees. An acute triangle is where all three angles are less than 90 degrees. So let's go ahead and take 3, 4, and 5. As a matter of fact, I'm going to get some pieces to help me. Okay, so I'm back with some paper clips to show a 3, 4, 5 right triangle. Right now, these 4 paper clips on the bottom and these 3 paper clips on the side make a right angle because it's straight left and right and straight up and down. If we have a 3 and a 4 with a right triangle, it takes 5 paper clips to make the longest side of the triangle, which is the hypotenuse. So it's like the problem we just saw, 3 squared plus 4 squared does equal 5 squared. But let's say we were making not a right triangle, but let's say it was an obtuse triangle. Let's say this angle, this 90-degree angle grew. If these 4 paper clips were angled wider, like this, all of a sudden, in order to connect this corner up here with this corner down here, 5 paper clips is not going to do it. We clearly need more paper clips. We just moved this angle farther away. We're going to need another paper clip or so. So what does that tell us? This side was still 3, and this side is still 4, but now this side is 6. Well, if 3 squared plus 4 squared is equal to 5 squared, then 3 squared plus 4 squared is clearly less than 6 squared. So when the two legs multiplied by themselves and added together are less than the square of the third side, then it's an obtuse triangle. But similarly, if instead of making an obtuse triangle out of our right triangle that we started with, again, we started with a right triangle here, and it was a 3, 4, 5. If instead of making it an obtuse triangle, what if we made it an acute triangle, which means instead of making this angle bigger, what if we made it sharper? Well, now, again, I'm using 3 and 4. I just moved that other angle closer, and I don't need 5 paper clips. I don't need 5 paper clips to get over there. So if 3 squared plus 4, now it's 3, 4, and 4, and all of these are shorter. So 3 squared plus 4 squared is clearly greater than just 4 squared, which we have 3 and 4 and 4 now. So if the sum of two sides is greater than the sum of the third side, then you have an acute triangle. So if I give you 3 numbers and I say, do these make an obtuse, an acute, or a right triangle? Let's just say I said the 3 sides were 3, 5, and 9. Let's say those are the 3 sides. Well, the 2 shorter sides are 3 and 5. So 3 squared plus 5 squared versus 9 squared. That's what we're looking for. Is this more, less, or equal? Well, 3 squared is 9, plus 5 squared is 25, versus 9 squared is 81. Well, 9 plus 25 is 34. 34 is clearly less than 81. So which situation is this? It's this one, where the sum of the 2 shorter sides is less. The sum of the squares of the 2 shorter sides is less than the square of the third side. So this would be an obtuse triangle. It would be obtuse. If you come up with something like, let's say 4, here are my 3 sides now, 4, 11, and 12. Well, you have 4 squared, 11 squared, and 12 squared to compare. So 4 squared plus 11 squared, sum of the squares of the 2 shorter sides versus the square of the third side. 4 squared is 16, plus 11 squared is 121, 12 squared is 144. So what do you get? 121 and 16 is 137. And again, that's less than 144. So it is again an obtuse triangle. If you get 2 that when they add up are greater than the third side, multiplied by itself, then you're going to get an acute triangle. But if it's like the one that we tried, where it's 3, 4, and 5, and they turned out to be equal, then it's a right triangle. Hopefully this is enough help. If you have any other questions, feel free to ask.